Okay, here we're going to look at one of the ordinary level exam questions based on orthographic projection and auxiliary projection. So let's have a read of the instructions, because sometimes some of these we can assume what we need to do, but we need to make sure we check exactly, because if we don't answer the question right, you won't get the marks. So first off, we have a 3D graphic of the deadly counter that we're going to be drawing today. We have the display unit, the clear glass or plastic display unit here on top. The figure down below shows us the dimensions of it in an isometric view, and part A is asking us to draw an elevation of this structure in the direction of this arrow here. So we need to figure out how long, how tall that object is. I've already done it here, so we can see here that the height is 110 and the length is 130 millimeters. We're then going to have to project a plan from this elevation. So we're going to be projecting as we come all the way up and look down. We're going to see how deep this object is. It's going to be 90 millimeters deep with a little bit of a taper here, 30 degrees. And we're going to have to do some working out in order to figure out some dimensions here. So we're going to then draw an auxiliary elevation of the entire structure, so not just one part. We're going to draw the whole structure projected from the plan, which will include the true shape of surface A. So we're going to need to be able to show the true shape of this in our auxiliary, so we have to do it in a particular direction. So let's get started. First off, I know my height is 110, so I'm going to come down 130 millimeters from the top of the page. I'm using an A3 page, just so that I have enough room. And so let's get started. I'm going to keep bringing this back in and out so you can have dimensions, but if you want, you might want to just take a picture of that. If I move my mouse out of the way, you can pause the video and take a picture there now, and then I'm going to put it away. So first things first, we're going to come down 130 millimeters from the top of our page, and we're going to draw our XY line. Now the placement is quite important in this case too, so I'm just going to draw my XY line fairly light at the moment across the whole page. We need to figure out placement. We need to figure out which way is our auxiliary going to go. So I'm going to put myself in the mindset that I've drawn my elevation, I've now drawn my plan, and my plan is going to come down at an angle across and back up like that, which means I'm going to be projecting my auxiliary somewhere that way. So I need to leave this top right hand portion of my page free if possible. So I'm going to draw my elevation over to the left hand side of my page over here. So I'll just move the camera a little bit so you can see the side of the page. So I'm going to draw my elevation. If I just move the camera a little bit, there we go. I'm going to draw my elevation just here somewhere. Straighten that up. Right, so my length is 130. My height is 110, so I'm going to draw a light rectangle showing where my elevation is going to fit. So 130. And I'm going to measure up 110, which will be up to there. And I'll just complete that light rectangle, and this is always a good point to remind you that this is where it needs to fit in order to conform to the dimensions that we've been given. So I've done that. Now I'm going to draw the overall height of the object. So if we have a look here, when we look in, we're going to see this face and this face here. It's all going to appear as one straight edge along, because we won't be able to see this surface here. And then we're going to see this little small rectangle and this inclined surface here, this inclined surface. So first off, I need to figure out the height of this line AB just here, which is going to be 80 millimeters long, and it's going to be 130 millimeters. So it's the total length. So I'm just going to come up 80, which will give me that point, and I can draw a solid line the whole way across, like so. I can also come down solid, because that's what I'm going to see on my left hand side. There we go, and I can draw the baseline in as well. So I'm just going to draw a short XY line, label that XY. Now the next thing we need to figure out is, because we can't figure out where this edge is here yet, because we don't have this length, I'm going to can't make it any brighter. Autofocus. Okay. I'm going to draw now this display unit on the top. So we need to figure out the length of the display unit. It's 60 millimeters long and it's 30 millimeters high. and it's sitting right in line with point A, so it's going to be sitting right here. If I label that point A, we're going to come over 60 and up to the top. So let's do that. So over 60 and come all the way up and back across. Now the reason I didn't draw in that right hand line just yet is because I wanted to do this whole thing in one go. Just looks a lot neater. There we go. So now we have, looking in at that display unit. We need to figure out now what this height is here. How are we going to do that? We can't do it looking from the front, we have to look from the side, but we don't need an end view. So all we need to do is figure out this profile. So if we break down this profile, if I extend this here, I'm going to use that fine liner using a red fine liner. If I extend this 40mm line all the way out, and if I extend this inclined line, we are after generating a right angle triangle. Now, I know the length of this base here, it's 40, not as far as this vertex, but if I come to 40 and then come up vertically, and I come up 30 and then project down at 30 degrees, because that's what I've been told this incline is at, I should be able to find this point here. And we're going to do that in what's called a ghost projection. So I'm going to project it this way. So I'm going to imagine I'm looking at this object this way. I know that it's going to slope down at 30 degrees. So I'm going to come down at 30 degrees. Like so. I'm going to come out from point A because that will give me a 30mm perpendicular height for this. So I'm going to come out parallel to my XY line, and I'm going to measure over 40mm because that's what length that display counter is. Now that does not hit this inclined line just yet, so I need to project that up to hit that line. I'm basically constructing just an end view of that object using construction lines. Now I have that point. That's what the end view of this object would look like. I just need to project back that height and draw it in on my elevation. Quick, easy, and it saves a lot of fuss of drawing a whole end view. Plus it leaves us the room now for our auxiliary when we get to it. So now that's as far as I can go with my elevation, I think. Let's double check. So I have this edge, I've done the whole display counter, I cannot find this edge and I cannot find this edge. I'm going to come back here, I could find this surface here which is going to be hidden detail, which is going to come over 50 from the left hand side. I'll get my ruler, we'll measure over 50 and we'll show our hidden detail using the correct line type. So our solid dashed line. So, there we go, we've shown our hidden detail. Now we need to move on to part B, because we cannot finish this just yet. So we need to move down to part B and project our plan. So first things first, taking our lengths, projecting them down. And again. And I'm gonna leave 20mm between my XY line and my plan. So there we go. 20mm seems to be a good number to work with. And there we go. I'm going to move the camera so you can see the plan now, hopefully, and the elevation. There we go. Right, so now I'm going to construct my plan. My plan is going to start here and work down, so this will be the back of the deli counter where the person would stand, and then this here will be the front where you would order your food, etc. So I'm going to start here where the back is longest. I'm going to project down my lengths as well. I'm going to project down the length of that portion. I'm going to project down the length of the actual display unit all the way down. And first off, before I start, I'm going to measure the total width of that object. Now if you look at your drawing, the total width of that object is 90mm. We've created a little rectangle where my plan should fit. and I am now going to start constructing it. So first things first, I can see that back edge, I can finish that. If I look perpendicular to it, you just see that as a straight line. Brilliant. I can measure down another 40 millimeters and finish my line just there, and that will give me one corner of that inclined surface. So that's surface A. There we go. I now have a corner of that. If I come down now at 30 degrees, I can use my set square for this. So I'm creating a 30-degree angle just here. Come down and hit the front of my object. I've now found the front corner. And before I forget, I'm going to project that all the way back up. So this is an edge view of surface A. Project that all the way back up and draw it in. I'm going to label surface A. There we go. Now I can come all the way across, solid, back up my 50 depth, so I can work out my 50, because if you look at the drawing, we can see that this here is 40, come all the way up, come parallel to the back edge, which means that this here is also 40, leaving 50 millimeter gap just here, because the total object is 90. So I'm going to measure then 50 millimeters back from this corner. Like so, project in, and finish off the overall outline of the object. The last thing I need to do now is show the display counter. We already know the width of that display counter is 40 millimeters. So if I just measure down 40 and bring that across, I now have my display counter finished. And that's my plan and elevation part A and B finished like that. Part C now, if we remind ourselves, it's asking us to draw an auxiliary elevation of the structure. So an auxiliary elevation means I project from plan, which it tells us here, which will include the true shape of surface A. So to find the true shape, I need to look perpendicular to this. So in order to see a surface flat towards me, we need to look at it perpendicular, like you are looking at this set square from the camera. You have equal distance of sight lines looking straight back up towards your camera there. So we need to move ourselves so that we're looking this way and project a new x1, y1 line parallel to this line. So that's the first thing I'm going to do. I'm actually going to take this outside corner to make sure I have enough room for it. So this is my furthest left point on the structure. This is my furthest right point on the structure. And I'm going to construct my x1, y1 line just here. Label it, and away we go. Now, while I have these 2 lines brought up, I'm going to find where they are in elevation, so I can see that that line, or that point, symbolizes this edge here. So I just take that height, because we're coming from plan, we're projecting an elevation, heights have not changed, so I just need to take the height that I already have for that line and measure it up. So I can either measure my 80 millimeters using my set square, or I could use my compass and step it off. I'm just going to measure it for today. There we go. I can draw that line in heavy now, because I know I'm going to see that edge. There we go. So I'm looking in, I'm definitely going to see that corner. I'm going to work my way down. I'm going to make sure I find every edge that I'm going to see. So I'm going to see this point as a line, this point as a line, this point as a line, and I'm going to see the display counter points as lines as well. I won't see these back corners or these back edges, so I need to show them in hidden detail. So first off, we're going to find surface A. Get that done and out of the way. Surface A is the same height as this point here. So if I imagine I'm after inclining myself now, if I come parallel to the ground, so the ground is a little bit tilted here, but if I come parallel to that ground, that means that this line is the same height as this line, which means it's just going to be 80 millimeters. I'm going to draw a construction line all the way across. And I can draw that in heavy. And just to prove that it's right, so this line here is the same height as that. So if I measure it here, it should be 80 millimeters, which it is. So dead on. So next line, we're going to bring up the other edge of surface A, project it up, perpendicular to our edge view of our surface A. So we need to have that edge view. Indicate that this is your true shape, so TS of A. There's your part C, part of it finished. Now we just need to complete the rest of the object. So same with this edge here. This edge comes up to that height, because if we look at the 3D graphic, we have found this line here, GH, we found the line EF, we found the line DC, we just need to find the line AB now. So AB is here at the front, it's this corner, it's the exact same height as the lines that we were just drawing. So I can just draw up as far as that construction line that I drew, and I can complete that top edge by just joining all them done, and we're done. Now I just need to finish off the display counter and then the back corners or edges as well. So I'm going to start with the point that I'm going to see first. Project it up, and I know that that's going to be this back edge, because if I look straight down, that's going to be at the back. It's going to be 30 millimeters higher than this object. So I can measure up a total of 110 millimeters, or add on my 30 millimeters. There we go. I'm going to project down again, parallel to my X1Y line, which makes this horizontal. I have now found that top point. I can draw that line in heavy. Like so. Next point I'm going to find, or points, what it says is I'm going to project up these two here. I know one of them is sitting on the counter, so there we go, we have it. And the other one is going to be up however high that is. So I'm going to use my compass for this. And I take my heights from my XY line. I'm going to set my compass accurately, hopefully, to that point. I'm going to find the projection line, put this on my X1, Y1 line, and swing it across. I now have that point found. Oh, I didn't even swing it to the right one. Okay, I double checked before heavying that in. So onto this projection line, swing it over to the right one this time, and now I can come create a construction line just there, and I have found that point. I can draw in that little upright, and I can finish that side profile by joining this back to its inclined plane. Now, the next corner or edge I'm going to find is this front one here as well. It's going to be the exact same height as this one here, so I can just draw up my solid line. And then the last point I need to find is going to be this corner just here. I can indicate that this is going to be a point. I can join my edge to it, and this is a good example of where parallel lines always remain parallel. There we go, these two are parallel up here, they're parallel down here, they're parallel there, they always remain parallel. Now I just need to show my hidden detail, so I need to show this hidden edge here. So that corner would go all the way from the XY line all the way up to that top point. So using my set square, I'm just going to show that in hidden detail. So I'm also going to see this internal corner here, so I'm going to project that up and do the exact same. And then the last corner, just over here, project that up. And there we go. So now hopefully you'll be able to see why I placed my elevation just here. I could have pushed my X1, Y1 up a little bit further, but it fit just fine. There was nothing colliding with itself. So first things first, we drew our elevation. We projected down to our plan. When we drew our plan, we then found this point, which then we projected back up. We found that. Then we came perpendicular. So we looked perpendicular to this. So perpendicular. Projected all our lines up, and we drew our new ground line. So if you imagine if I rotated that like this now, so that it would be horizontal in your camera view. This is now our ground line, and we just measure our heights up. So when we got that done, then I found all the lines I could see, so I stood myself here. I know I'm going to see this surface, I know I'm going to see that surface, and I know I'm going to see that surface, so I can draw all of them in heavy. I know I'm going to see this edge here, or this surface, the front surface, and I'm going to see that top inclined surface. I cannot see this back wall, this back wall, this back wall, or this back wall, so I need to show these as hidden details. Hopefully that makes sense. If you have any questions, let me know. Thanks.